right, so now we're going to intersect a constructible line and a constructible circle. So just like before, we have some field of numbers that we know are constructible. And so we're thinking maybe all the numbers that we have are rational numbers. And so we want to write down a line and a circle with rational coefficients. So our circle, once we expand everything out and moved everything to the same side of the equation like we did earlier, our circle will look like x squared plus y squared. If it's not centered at the origin, it will have some ax and some by and some c equal to 0. Okay, and the a and the b and the c, those are all coefficients in our field f, so maybe they're all rational or something like that. That's our circle. Our line looks like dx plus ey plus f equals 0. And so like I said, a and b and c and d and e and f are all in our field f. Okay, so I want to intersect these, meaning I want to solve that system of two equations. One way to do that here is to solve the line equation for something like x. So we could do solve the line for x. And that's only going to work if d is not 0. If d is 0, then we'd solve for y instead, and we'll get a really similar set of solutions. So we're going to assume that d is not 0 and solve for x. So what we would get is that x is minus f minus ey over d. Okay, so that's our equation for the line solved for x. And now we're going to plug this in to the other equation. So this plug this in to the circle equation. So the circle starts with x squared, so we would have that minus f minus ey over d squared, and then we had plus y squared, plus a times x was the next piece, and so we'll have minus af minus aey over d, and then plus by, and then I think it was plus c equals 0. Let me go look really quick. Yep. Okay, so there's our circle equation, and now my goal is to solve for y. And notice there are y's all over the place. So that one I just fixed as a y, there's a y, there's a y. So what we want to do first is sort of combine like terms. So there are a bunch of those that are y squareds, right? When I do that, I'm going to have some crazy coefficient, which I'm just going to call a in front of a y squared. And then once I combine all my like terms, I'm going to have some coefficient that I'm going to call capital B in front of y. And then I'm going to have some set of constant terms that I'm going to call capital C. This capital C, maybe I'll add some little bars to it so it's not the same as the lowercase c up above, because I have some other constant terms up here too, like I have this minus af over d. That's going to get lumped to this capital C just like that is, and there's other stuff in there also. All right, so this becomes kind of a mess, and I'm just avoiding doing it basically. But we know what's going to happen is I'm going to use all those coefficients. I'm going to square everything. I'm going to combine like terms appropriately. And what I end up with is going to be something in this form. Moreover, if a, b, c, d, e, and f are all rational numbers, then certainly capital A, capital B, and capital C will be rational numbers too. I'm not doing anything that takes me out of the rationals. I'm just multiplying, dividing, adding, subtracting. And so we can write down that A and B and C are still in that field F. We haven't left our field yet. All right, I want to solve this for y. When I do that, notice I used capital A, capital B, capital C because this is a quadratic equation, and so we know what the solution is going to look like. It's negative b plus or minus square root b squared minus 4ac over 2a. And now, is that in F? That's our next question. And it might be, or it might not. So the square root of b squared minus 4ac might be in F, or it might not. But the point here is that it is in a field extension of F. If we could take F and expand it by adding in square root of minus b squared minus 4ac, then that number, that solution y, is in that field. Okay? So the point x, if we look back at where we solved for x, it was made of f and e and d and y. Y lives in this field, so y is in f adjoin square root of b squared minus 4ac. And thus, x, which was made out of a couple of rational coefficients, remember the f and the e and the d, along with y. So x will certainly be in that same field, f adjoin root b squared minus 4ac. Okay? And notice that b squared minus 4ac already was in f. So all we had to do was take something in f and allow the square root of that thing. So instead of being just in the rationals now, we're in something like the rationals adjoin root 2. If b squared minus 4ac is 2, then what we've had to do is say, now you need to allow square root of 2 also. Okay? So what is we might have left, so our intersection point might have left our field. It might not be in F anymore. But it is in F adjoin root D, and I'm going to change that to a capital D, where that capital D, okay? So all we've had to do is expand our field a little bit. So we might have left the rationals, but all we did was end up in a rational adjoin the square root of some rational. Okay? Great. So what's left is to intersect now two circles, and we'll do that in one final video.